more so than other people's wages, right? Like maybe we don't want to underpredict the wages for like very poor people for policy reasons. In which case we can take the same sum of the squared residuals and we can put some coefficients in front of this. We can put like more weight on Mr. T's prediction versus Tom's prediction. And that would not be ordinary least squares because we're kind of like choosing weights for the various residuals. Okay. You guys have you guys heard of, you guys have seen ordinary least squares before? Some of you may have seen it in Econ metrics class. If you've not seen it in Econ metrics class, this is what it is. And this is basically something. Okay. So what we want to do is we want to minimize the sum of the square residuals, right? Is this going to be a positive quantity or, are we good, Shannon? Good, okay. Is this going to be a positive quantity or a negative quantity? It's going to be, and why is it going to be positive?
They're all squared.
Because they're all squared. So if we have something that's positive, and we want to find the minimum value of it, right? That's the same as finding the maximum value of the negative of it. Does that make sense? Okay. So like, for example, right. Okay. So we want to minimize SSR or maximize minus 1 times SSR. Does that make sense? So for example, like if we have like, let's say if we have like SSR values that are 2, 1, and 10, right? Which one is the minimum? Which one is the minimum value? Like this, these correspond to different alphas and gammas. 1. So 1 will be the minimum, right? Now let's look at minus SSR. Minus SSR. Minus SSR is just going to be minus 2, minus 1, minus 10. Right? Which one is going to give us the maximum of minus SSR? Negative 1. And I should have mentioned that each of these, so maybe this is like gamma hat 1, alpha hat 1, and this is gamma hat 2, alpha hat 2, gamma hat 3, alpha hat 3, right? So these are just different, like guesses that we had. And so this guess of alpha 1 and alpha 1 and gamma hat 1 gives us the SSR, gives us the sum of square residuals of 2, and so on and so forth, right? And this is just to show you that maximizing SSR is the same thing as minimizing SSR is the same as maximizing the negative event. Okay. That may have been like too slow, but I just want to make sure that we don't lose anything. Okay. So what I'm going to do is I'm going to erase this. Okay, so we choose gamma hat, alpha hat, to maximize minus SSR, which is the same thing as minus 1 over n. And this really is the average of the sum of the squared residuals. I equals 1 to n epsilon I squared, right? Now, remember our econometric model, right? Our econometric model said that the log of wages is equal to alpha plus gamma SI plus epsilon I. So let us rearrange this to find out exactly what epsilon I is going to be, right? And let me do one simplification. So instead of writing log wages everywhere, let's just write this as y. So let's just define yi to be the log of wages I. So this is just a transformed income variable. Okay. So what we'll have is that yi is equal to alpha plus si plus gamma si plus epsilon I. And that's going to imply that epsilon I, the things that we don't observe, is going to be what are your actual wages minus alpha plus gamma plus si. So this is like the prediction. everybody follow this so far?
So was that the equation?
So this here?
You're finding your other like errors.
So, okay, so we want to figure out what are the right values for gamma and alpha. And they're going to be the values that that are going to minimize the sum of the square residuals or maximize the minus of it. And so in order to find them, what we have to do is we have to construct what these prediction errors are. And so for a given guess gamma hat and alpha hat, the prediction error is going to be what's the actual observed wages minus the predicted wages. So going back to here, these are the actual observed wages, and the predicted wages is going to say that given this year of schooling, will we predict this? Okay. Everyone sees that? Okay. All right, good. So we have this, and so what we can do is we can plug this back into here, and then take derivatives, right?
Dr. Blair,
Yes?
I've never really been good with changing signs, but should gamma SI be negative?
Yes. This is that was a mistake. Thank you very much. Right. So let's just take a 3-minute bathroom break, and when we come back, what we'll do is we're going to solve this optimization problem.